Most of the students have given CBSE board exam 2026. Okay. So I want to solve all the MCQs. I have got this message through the students, and I'm solving set number 1 here. Sorry, set number 3 here. Okay. In set number 3, we have some questions here. All MCQs, 12 MCQs I'm solving. But you know, you can connect all this solution with the set 2 and set 1 also. I don't have set 1 right now and set 2. So some of the questions, maybe 2 or 3 questions are different. So separately I will make the solution on that. But right now I'm solving set 3 question number 1. So let me read this question here first. Question is, a wire gradually stretched to make it 100% longer. Its resistance will increase by what percentage? 100%, 200%, 300%, 400%. Let's see. So whenever you are stretching the wire, this is the wire. Suppose that its original length is L and its resistivity is low, and its area of cross section you can say that this is A. Then I can write its original resistance R naught, which is equal to rho L upon A. But according to question, you have to increase the length. Stretch means you are increasing the length, basically 100% increment. Okay. So if you increase the length by 100%, it means L plus 100% of L. This is the increment. So I can write it will be L plus percentage means divided by 100 into L. It will come 2L. It means its length become 2L, right? Then resistivity will not change when you stretch a wire because resistivity depends upon the material and temperature, that is remains constant. But area of cross section will decrease by same way. If it is increased by n time, area of cross section become A by 2 because length is increasing by 2. Then new resistance which we call R dash is equal to rho is same, length become 2L and area become A by 2. Okay. Then you can say it would be 4 time of rho L upon A. If you want to calculate the percentage, I will write final resistance minus by binomial theorem upon initial resistance into 100. When you have percentage more than 10, so you can use this formula. Otherwise, you can use error technique here. Final resistance you are getting 4 rho L upon A. Okay. Minus initial is rho L upon A. And it's coming divided by rho L upon A. All will cancel out into 100. You are getting 4 minus 1 upon 1 into 100. That will come 3 into 100, 300%. It means resistance of the wire is increased by 200%, 300%, sorry. Let's come to the next question. A closely bound long solenoid of self-inductance L, let this is solenoid. Its self-inductance is L. Now it is cut into two equal parts. Suppose that it has n number of turns and current flowing is I. Okay. So here, if you cut it in two half, number of turns become half. Here also number of turns become half. I hope it's clear to all. Now self-inductance has two formula. One is mu naught n square upon L into A. You can write it in terms of small n also. Small n is total number of turns upon L. So L depending upon what? Area of cross section will be same here. Okay, only you are changing the length, and length become what? L by 2 for each. So this is the original. I can write L. What is the new self-inductance? Let this is L dash. Mu naught is same here. Number of turns become n by 2. So if you make the square, it become n by 4. Into area of cross section is same, and length become L by 2. Okay. So it become 2 will come up 2 upon 4 into mu naught n square upon L into A. 2 upon 4 means 1 by 2. And this whole value is original self-inductance, this one. So I can write into L, and answer is coming L upon 2. Okay. Let's come to the question number 3. Which of the following characteristics of electron determine the current in a conductor? You know, here drift velocity, thermal velocity is given. Drift velocity and current is given by NEA VD. VD is the drift velocity, right? So current is directly proportional to drift velocity here. It means current is determined by the drift velocity. So option A is coming correct. Here student, you have the confusion about the thermal velocity. Basically what happened, suppose that these are electrons, they are moving in random direction. Okay. So if you increase the temperature, I mean to say thermal velocity. If you increase the thermal velocity, it leads to the randomness. Randomness shows that initial average velocity becomes 0, then average velocity becomes 0. If average velocity becomes 0, it will not contribute the current. Then average current we can write it is 0. So current is only confirmed when you change the drift velocity. Okay, please be careful. So that's why option A is correct. Let's see the question number 4. Dear children, in this question you can see radius is already given. Obviously let this is R1 radius and this is R2 radius. So one thing is very clear in this question. You can simply say R2 is greater than R1. Okay. So whenever charged particle projected in the uniform magnetic field here they have given same velocity. It means velocity is same. And uniform magnetic field, it means magnetic field is also same. But radius is different. What is the formula of radius? We can say in a circular motion, only centripetal force is responsible, will provide what? Centripetal force is provided by magnetic force, BBV. When we cancel out, you can calculate the R from here. R is MB upon QV. These two factors are same. That's why I can directly write radius is directly proportional to M upon Q. So I can write here M2 upon Q2 greater than M1 upon Q1. But according to demand, we can write it M1 upon M2. Okay. M1 upon M2 is greater than what? Q1 upon Q2. You can write it this way also. M2 upon M1 is greater than Q2 upon Q1. When you reciprocate it, it becomes M1 upon M2 less than Q1 upon Q2. Let's see the option here. Sorry. Q2 upon Q1 here. This is Q2. Q2 will come down. Q1 will go up. Okay. This is not the answer. So when you reciprocate again, it become M1 by M2 upon Q1 by Q2. C option is coming here. Okay. So dear children, in mathematics, when you reciprocate the numerator denominator greater than become less than. So C option is coming up according to me. Okay. Now next, Paschen series. Lemon, Balmer, Paschen, bracket, P fund. Okay. It lie in ultraviolet region. Its wavelength lie in visible region, and all three will lie in infrared region. So that's why right option is A, infrared region. Next one is sixth question. Dear children, question number 6. Kinetic energy of charged particle is increased by 4 times of its initial value. Then what is the de Broglie wavelength? You know de Broglie wavelength, formula of de Broglie wavelength is 1 upon root, let me see, lambda is h upon root of, I'm not deriving the formula, I'm directly writing the formula, 2 into mass into kinetic energy. Okay, so you can see here kinetic energy is increased by 4 times here. So these are constant things for electron. That's why lambda is inversely proportional to root of kinetic energy. Then formula become lambda 1 upon lambda 2 is equal to inverse ratio Ke2 upon kinetic energy of 1. Okay. So what is increased here? Kinetic energy is increased. It means initial kinetic energy is same, but final kinetic energy K2 is increased. How much time? 4 times of its initial value. It means kinetic energy plus 4 of kinetic energy. Okay. So you can write here as kinetic energy is inversely, directly you can say, okay, no need to solve this way. You can solve directly. Wavelength is inversely proportional to kinetic energy, root of kinetic energy, right? The wavelength is inversely proportional to root of kinetic energy. It is increased by 4 times. The root of 4 become 2. Then new wavelength leads to lambda by 2. So lambda by 2 means it's coming 50% of it. Okay, so let me check by other way also. Here only. Dear children, solution may be, error may be there. You can try later. Okay, but right now I'm solving by this way. So suppose that kinetic energy become, if you want to calculate the percentage, the percentage means, but simply no need. Here they are calculated already. 50% increase or decrease. That thing I want to calculate. Okay. As lambda is inversely proportional to kinetic energy. If kinetic energy increase, it means wavelength decrease. 50% we already know, it means it is decreasing by 50%. Remember this thing. Okay. Let's come to next solution. In a reverse bias, suppose that this is PN junction and you are reverse biasing is P side negative and N side positive. Then what will happen here? This is a depletion region. Here it is negative. Here P side number of holes are there. Then it is attracted. Then width will increase. Then depletion region will increase. Depletion region increase means what? That width will increase means what? Resistance will increase. If resistance is increasing, it will drop, more voltage is dropped. Okay, voltage drop means it will consume the voltage. So where it fall? Near to the depletion region. So that's why right option of this question is depletion region. Okay, now next question is, let me read the question first. A coil having 100 closely wound turns, so you can write here number of turns are 100. Okay, and area of cross section is given 300 millimeter. So 300 milli means 10 raised to 3 and square of that. It will come 300 into 10 raised to 6. Simply you can say 3 into 10 raised to power minus 4 meter square. And current is also given here. Current is 5 milliampere. Milli means 10 raised to 3 ampere. You need to calculate the magnetic moment. You know magnetic moment is Ia for the current carrying loop. But if number of turns are there, you can multiply it by n. So it become I is given 5 into 10 raised to power minus 3. Area is 3 into 10 raised to power minus 4. And number of turns are 100. So you can write 5 3s are 15. Base are same, power will add minus 7 into 10 raised 100 means 10 raised to 2. Now again you can write 15 into 10 raised to minus 5. Let me see the answer. No, it is 1.5. When you shift the decimal, it will become 10 raised to power minus 4 ampere meter square. So that's why right option is coming C here. Okay. Now we go to the next question. An AC voltage. It is written here V is equal to 14 and sine sinusoidal voltage 314 into T volt. The average value, effective means RMS value, okay? Over a cycle means single cycle. You know single cycle means where time varies from 0 to T. Already you know average value of voltage, which is called average EMF, that becomes 0 because over the full cycle average value is 0. What about the RMS value here, ERMS? That is equivalent to E naught upon root 2. So E naught means peak voltage, which is given 14. 14 upon root 2. You can multiply or divide it by root 2 here. So it becomes 2, 7. That becomes 7 root 2. So you can multiply it. 7 into root 2 is 1.414. I've calculated it. It is coming around 9.8 into 99. So which is approximately 10 volt. So that's why option is 0 and then 10 volt. So which option is coming here? C option is coming here. Now let's come to the next question. Amplitude of electric field. Amplitude means E naught, maximum value. And amplitude of magnetic field means B naught. In electromagnetic wave radiation, 5th chapter, you studied it, which is equal to velocity selector, or you can see this formula also cross field. Cross field, it is also called velocity selector when charged particle enters uniform electric or magnetic field. Okay, you will get this. So when you get this, so V, a refractive index is C upon V. And when you want to calculate the weight is C upon mu. You can put this value here C upon mu. Okay. So C is the speed of light, 3 into 10 raised to power 8, and mu is 1.5. It will come 30 upon 30 upon 15 into 10 raised to power 8, and finally that is 2 into 10 raised to power 8 meters per second. You want to know that from where it is coming. When you have a uniform electric field, 2 plates I am taking, this is uniform electric field from positive to negative. If you have uniform magnetic field as well, when charged particle enters, it will be undeviated. Okay, undeviated means electric force between the plates become equivalent to magnetic force between the plates. Electric force is nothing, that is QE. You can write it QE naught, and magnetic force is V B naught BB QBB. Okay, so QQ will cancel out. From here velocity is coming what? E naught upon B naught. Okay, so this formula is expressed by this way. Let's come to the next question. This is very tricky or lengthy question asked this year in Cbse board exam, and it will take time to solve. I have solved, dear children, right now very quickly. I mean to say calculation is done by calculator. If any mistake later on when you express it properly, I'll see after checking the board papers, I will check its answer, but whatever I have solved right now that I am telling in front of you. And in this case, calculation of HC is important because this is the wavelength given here. Wavelength is 33 1 nanometer. Nanometer means 10 raised to minus 9 meter. Wavelength is given here. Okay. So photoelectric emission possible or not, how would you identify that? For that, you simply remember whatever incoming energy is there, it should be greater than or equal to what? Work function phi naught. Okay, then only emission is possible. That is SC upon lambda because wavelength is given greater than or equal to phi naught. Why this way? You can solve it. It means whatever energy you are giving to the photosensitive metal, like sodium, potassium, or calcium, that should be greater than or equal to work function given here. When you solve HC by lambda, lambda is given. I got this answer was 3.75 electron volt approximately, which is greater than phi naught. It means if energy is greater than phi naught, obviously emission is possible, otherwise not. If you see carefully here, when you see the sodium here, it is 9.1, 1.92, 2.15, 3.2, and 4.17. Only this last element has more work function than energy striking on the metal. It means it is not possible to emit the electron in this metal. But rest of three, it is possible. So this is yes and this is no. But you have to check the data. So according to me, this answer, which one is? None of them, no. Only MO will not show photoelectric emission. According to me, this is the right answer. Let's come to next. In an experiment of photoelectric emission, intensity of incident radiation is halved. It means intensity of incident radiation become half. And frequency is constant. Frequency is constant according to the data given in the question. And maximum kinetic energy of photoelectron will remain same. Cutoff potential will increase. Photocurrent will increase. Cutoff potential. First of all, cutoff potential, which is called stopping potential also. It depends upon frequency, dear children. Be careful and independent of intensity. Dependent of intensity. It means if intensity is off, it won't be affected. Stopping potential, frequency is same. It means stopping potential will be same. Cutoff potential will be same. So I can say cutoff potential will increase. Maximum kinetic of photoelectron remains the same. Photocurrent is independent of frequency. Okay, it is depending on the intensity only. The photocurrent I can write here directly proportional to intensity. If you make it half, photocurrent become half. Okay, it means current is not decreasing, it is increasing. It means third option is wrong. What is left option? Cutoff potential will increase. That is also wrong. Cutoff potential decrease is also wrong. It means only one option is there. Even you know maximum kinetic energy in this experiment, we can write EV naught. It means if V naught is constant, it means kinetic energy is constant. If kinetic energy is constant or same, then according to me, answer will be B. Okay. So I hope these are the questions. One of the question I got from the message, that is, I want to solve that also because video is still in the progress. So one more message I got. Okay, no problem. So dear children, if you have the query in the other set also, one of the question I remember in set 1, I think that is based on the resistivity. Please be careful about that. There are two wires of different material, one having resistivity rho 1, having resistivity rho 2. Area of cross section will be same. Length is also same according to that set 1. This is set 1 and first question. Okay, I remember it. I don't have the PDF right now. So if they are connected in series, let its resistance, like resistance you can connect in series, R1 plus R2, okay, in series. Obviously what you are doing basically, in series you are joining two wires. Its length is L, its length is L, and total length become 2L. So that's why total resistance become rho into 2L upon A but individual resistance is rho 1, L is same, area is same, plus rho 2, L is same, area is same. L by L by L by you can cancel out. Then this rho become what? 2 will come down. That become rho 1 plus rho 2 into half. So by this way you can solve. Okay. So this is very fresh. After 1 hour I am delivering, I am recording this solution. Dear children, there may be error. So upcoming day you'll get the correction also. If you have the idea, you can put the comment in video. And these are the best thing for you. Quickly you can analyze so how many questions out of 12 is correct. Thank you. Thank you very much to everybody.